Today on Quickly Quantum, did quantum computing spend this week proving itself or proving its critics right? We've got a hardware claim big enough that IBM's own chief scientist says the field is firmly in the quantum advantage era, running smack into a growing chorus of scientists asking whether any of these advantage claims actually replicate. Before we get there, there's a lot of ground to cover. A new U.S. free space quantum network link the weekday feeds missed entirely, a Wall Street Journal piece on companies racing to get ahead of quantum encryption threats, and a genuinely nasty backlash calling parts of this sector a scam. Welcome back to Quickly Quantum, your daily brief on the quantum frontier. It's Saturday, August 22nd, 2026, time for the weekly recap, where we round up everything from the week, plus a few big stories that slipped through the cracks until now. Let's get into it. Let's start with the story that flew under the radar this week, because it might be the biggest one. IBM and the University of Chicago say they've pulled off a verified, trusted quantum advantage using 70 logical qubits. Quick refresher for anyone new. A logical qubit is a bundle of many noisy physical qubits wired together with error correction so the group behaves like one clean, reliable qubit. 70 of them ran a doped Clifford circuit, a quantum circuit mixed with just enough non-standard gates to make it hard for a classical computer to fake, using something called space-time codes to catch errors mid-computation. The whole job finished in about 15 minutes, and IBM's Jay Gambetta said the company is now, in his words, firmly in the quantum advantage era. So is this the quantum advantage era, or just a really good demo? This is IBM revisiting familiar territory for the show. We've noted before that IBM needs quantum to be the answer to a bigger strategic bet, and whether the market's actually buying that long-term has stayed an open question. Today's result doesn't settle that, but it does something smarter than most advantage claims. IBM published a formal statistical fidelity bound and put the whole dataset on a public tracker, specifically so outside groups could check its work. And when you check the fine print, the certified fidelity bound comes in at 0.284 at 95% confidence. Not nothing, but narrower than quantum advantage era makes it sound. That gap between the headline framing and the certified number is worth sitting with. A real hardware feat, with the marketing running a little ahead of the math. Here's another one that weekday coverage missed entirely. Brookhaven National Lab and Stony Brook University just built the first free space quantum network link in the US, sending single photons and entangled photon pairs 13 miles, about 21 kilometers, through open air between Stony Brook's Quantum Watchtower and Brookhaven's Quantum Lighthouse. And they didn't just do it once. They verified entanglement arrival both at night and in daytime conditions. As Brookhaven Lab put it on X, the nation's longest quantum network is one step closer to becoming wireless. And that's the real headline here. This 13-mile hop folds into an existing 161-mile fiber network across 8 nodes on Long Island, with a third node planned at Yale that would stretch the wireless leg another 30 miles across Long Island Sound. Now, quick gloss for anyone new to this. Entanglement is the quantum link where measuring one particle instantly tells you something about its distant partner, and a quantum network uses that link to eventually do things like tamper-evident communication or coterning quantum computers together. This free space approach is the wireless cousin of the fiber optic version, useful anywhere you can't or don't want to lay cable. The catch, and it's a real one, free space optical links live and die by weather and line of sight. A fixed 13-mile lab-to-lab shot is one thing. A real metro-scale mesh network that survives clouds, rain, and buildings in the way is a much harder engineering problem nobody's solved yet. Still, paired with a record-distance fiber result coming up later in this recap, this was a genuinely good week for people trying to build a working quantum internet. We covered this earlier in the week, so here's the short version. The Wall Street Journal profiled corporate quantum spending, and Allstate's CEO did the quote of the week: "Get on the train." The newcomer's gloss. That means committing real budget to quantum research years before the technology is expected to pay off commercially, on the bet that catching up later costs more than getting started now. That phrase is worth pausing on for a second, because "get on the train" carries exactly the kind of urgency that shows up whether or not the underlying technology has actually caught up to it yet. It's the same fear of being left behind logic every emerging technology cycle produces, where budget decisions get made before the return on that budget is provable one way or the other. Here's the tension worth sitting with, though. Executive enthusiasm from insurance and finance leaders has run well ahead of demonstrated returns before, in both the AI and blockchain cycles. Allstate might be completely right to move now. Being early on infrastructure and talent has its own value even before the technology matures. But get on the train rhetoric deserves the same scrutiny this time around that it got in those earlier cycles. Fortune ran the number that's been sitting in the back of this show's mind all week. Over $2 trillion in digital assets potentially exposed to a future quantum-capable codebreaker in what they're calling the Great Quantum Migration. So how worried should you actually be about your crypto wallet right now? Quick gloss first. Today's quantum computers can't break the encryption protecting your bank account or a blockchain wallet, but a large enough error-corrected future machine theoretically could, which is why post-quantum cryptography, encryption built to resist that future attack, has turned from a theoretical exercise into an active migration project. This connects to a broader post-quantum migration story running underneath the week's headlines. Reporting also pointed to the bipartisan grid security bill, Crypto4a's FIPS validation, and Blockstream's post-quantum wallet demos, all part of the same migration anxiety. Worth saying plainly, $2 trillion is a risk exposure estimate, not a countdown clock. Nobody credible claims a cryptographically relevant quantum computer exists today. But the migration itself takes years to execute even once you decide to start, which is exactly why the urgency is showing up now instead of later. Then there's the story that might be the week's real thesis statement. Quantum computing may be facing its own replication crisis. As @NewScientist put it on X, quote, "A review of thousands of scientific papers about quantum computers finds that most don't provide codes that can be tested on independent devices or that those codes don't work," end quote. Quick gloss. Replication means another lab can rerun your experiment and get the same result. It's the basic test that separates real science from a press release. And a field built on claims that a quantum computer did something a classical computer couldn't has a special obligation to make that checkable. So what actually counts as replication when the whole point of quantum advantage is that classical computers can't check your work directly? Here's why I keep coming back to this one. It's the exact tension sitting inside our first story today. IBM's 70 logical qubit claim is probably the most credible answer to this problem I've seen so far. Public data, a formal fidelity bound, an actual tracker anyone can audit. That doesn't erase the concern. It's a genuine attempt to answer it, and this week gave us both the disease and maybe the first dose of medicine. Staying with the friction between hype and substance, this was also the week critics started calling parts of the quantum sector a scam amid intense retail investor enthusiasm and volatility around IonQ and peer stocks. And look, the timing is almost funny, because in the same week, IonQ kept putting out genuine technical news of its own, including a chemistry paper with NVIDIA we'll get to in a second. So which is it? A scam or a serious hardware company? Honestly, that's the wrong question, because stock price mania and legitimate R&D progress are two separate things happening on the same ticker. A stock can be wildly overhyped by retail traders chasing momentum, while the underlying engineering team keeps doing solid, publishable work. That distinction matters more the louder both sides shout. Conflating the two either dismisses real research or excuses an inflated valuation, and this week, IonQ managed to generate headlines supporting both readings at once. That IonQ and NVIDIA paper deserves its own few minutes because it's a legitimate technical counterweight to the scam narrative. The result was validated using NVIDIA's CUDA-Q and cuQuantum software stack, NVIDIA's software layers for running and simulating quantum circuits on its own GPUs. Now, quick gloss on why chemistry matters here. Simulating molecules is one of the most cited real-world use cases for quantum computers, because the way electrons behave inside a molecule is itself a quantum problem that classical computers struggle to model efficiently. A 54% error cut in that kind of simulation is a genuinely useful number if it holds up. And that's the catch. This is a vendor-published result, validated on the vendor's own simulation stack, and independent peer review hasn't caught up to it yet. That's precisely the pattern this week's replication crisis coverage is worried about. A result that looks great, gets a press cycle, and hasn't been checked by anyone without a stake in the outcome. I'm not saying it's wrong. I'm saying it belongs in the promising but unverified pile until someone outside IonQ, Qubits, and NVIDIA reruns it. And given the money riding on IonQ's stock right now, that verification matters more than usual. Still, pairing real hardware, a named error mitigation technique, and a specific workload is more concrete than most of what's circulating in this sector right now. Now to policy, and this is a big one if it holds up. I want to flag this clearly. It comes from one analyst's reading of the document, not the primary White House release, and we haven't independently confirmed the specifics. How an investment curve would actually work, for instance. Treat the framing as directionally real and the details as provisional until the official text is out. What I can say with more confidence is that this tracks with a pattern that's been building all year, where quantum policy keeps escalating from individual agency guidance into top-level national strategy. It also lines up with the FBI standing up a new quantum counterintelligence team. The security and espionage angle on quantum is no longer a side conversation. It's becoming the main one. If even half of what's reportedly in this strategy survives to the official version, it puts quantum computing in the same national priority tier as AI for the first time at this level of government, which matters for funding, for export controls, and for how seriously everyone building a competing roadmap takes the US one going forward. And regardless of the exact investment curve mechanics, the direction is unambiguous. Washington increasingly sees quantum the way it saw semiconductors a few years back, too strategically important to leave to market forces alone. And finally, remember that promise from earlier about a record distance fiber result? Here it is. A team based at the University of Science and Technology of China in Hefei demonstrated entanglement between quantum memories separated by a record 420 kilometers of optical fiber. Quick gloss. A quantum memory is a device that can store a quantum state, like an entangled photon's information, long enough to actually use it, instead of the state just passing through, which matters if you ever want a quantum network with stopping points along the line instead of one continuous, lossy stretch. Put this next to the Brookhaven and Stony Brook free space link from earlier, and you get a real picture of the week. One team pushing distance over fiber in China, another proving a wireless hop works in the US, both chasing pieces of the same eventual goal, a working quantum internet. The honest caveat, same as always with these records. Long-distance entanglement demos usually run at very low photon rates. Proving it's physically possible at 420 kilometers isn't the same as making it fast or cheap enough for real traffic, and that gap likely still runs several years. That's the week. A hardware claim big enough to make headlines, a replication crisis serious enough to question them, and enough policy movement in Washington that this stopped being just an industry story. If any one story here caught your ear, that's the one worth sending to a colleague who still thinks quantum computing is science fiction. This has been Quickly Quantum, an AI-voiced podcast created and built by a real human using today's cutting-edge technology. Nothing you heard on this show is financial advice. I'm Brian Lampert, and I'll catch you all tomorrow. Take care.